Norgutel lets you create new experiences by securely sharing your real-time location and route with your mates. This video shows how Norgutel protects your data using end-to-end encryption. Let's walk through Norgutel's security scheme with an example. Alice and Bob are sightseeing together. In the next few hours, they plan to explore separately, but they want to know where the other is, so they can find each other later and share stories. They also want to make sure no other person or machine is able to access their information. For this, Alice creates a new Norgutel session and shows its QR code to Bob, who scans it directly off the screen. The QR code only exists in 2 instances in their Norgutel apps on their devices, as it was not sent through any communication channel. For both Alice and Bob, the Norgutel app derives the same set of session keys from the QR code. The keys will be used to encrypt and authenticate their data shared within the session. Norgutel apps use a Norgutel server publicly available on the internet, so that they can connect no matter where they are, or which provider's network they use. The Norgutel server's job is simple: to relay messages between apps running the same session at the same time. Before starting the communication, each Norgutel app negotiates an additional set of ephemeral keys with the Norgutel server. These keys are unique for each app, and they are used to secure the channel between the device and the server. These keys are renegotiated every time a session is started. When Alice shares her location with Bob, her data first gets encrypted and authenticated with the session keys derived from the QR code. This creates ciphered data that only Alice and Bob can decrypt. Next, the unique identity of the session is attached to the ciphered data. The session ID is derived from a different part of the QR code. This is to let the server know which session the data belongs to, so that the server can select the right target devices for replication. The ciphered data with the attachment is wrapped in an outer layer of encryption and authentication, using the ephemeral keys negotiated between Alice's app and the Norgutel server. The resulting data is sent to the Norgutel server, which decrypts the outer encryption layer and interprets the session ID. Assuming that Bob has also launched the same session, the server will find Bob's current internet address as eligible recipient for the inner ciphered data. The server's knowledge about any session participant is limited to the session ID, as it is unable to decrypt the inner ciphered data itself. Therefore, trusting the server is not necessary to maintain end-to-end privacy. The server recreates the outer layer of encryption and authentication around the inner ciphered data, now using the keys negotiated with Bob, and sends the resulting data to Bob. Bob's app decrypts both the outer and inner layers of encryption, as it has both its ephemeral keys and the session keys derived from the QR code. Alice's location is now available at Bob within his Norgutel app, transferred securely and end-to-end. The same security scheme is used for any number of participants within a session. In summary, the QR code is the key to protect your data in end-to-end. It is up to your use case whether the secrecy of your session's code is desired, for example, for personal communication, or on the contrary, you wish to publish the code to attract visitors to an open event. No matter how you use Norgutel to create your own experience, your and others' data are encrypted in end-to-end for ultimate privacy. That's all for now. Thanks for watching.